Hello, everyone. Let's begin by learning about the first task in chili pepper production techniques, understanding chili peppers. Chili peppers are memorable flavor you both love and hate. So, what exactly is the heat in chili peppers? Let's start by watching a short video to find out.
Welcome to the world of capsaicin. Chili peppers are a common fixture on our dining tables, and that fiery, spicy sensation they bring is simply irresistible to many. But where does that feeling actually come from? The answer lies in a compound found in chili peppers called capsaicin. This active ingredient binds to sensory neurons in mammals, triggering a burning sensation, what we commonly describe as spicy. This isn't a taste sensation, but a form of pain perception. Whether a chili pepper feels spicy or mild depends on how much capsaicin it contains. Naturally occurring capsaicin is primarily extracted from the fruit of capsicum plants, a member of the nightshade family. It's most concentrated in the placenta, followed by the flesh, and least in the seeds. That's why people who are sensitive to spicy food often remove the inner ribs and tips of the pepper to reduce its heat. Capsaicin is soluble in alcohol and other organic solvents, but not easily dissolved in water. So if you get chili oil on your hands, simply rinsing with water won't help much. It's better to wipe with an alcohol pad first, then rinse with clean water. In moderation, chili peppers can help strengthen the stomach lining, enhance its resistance, and play a role in protecting the gastric mucosa. They have also been shown to have fat-lowering, blood pressure-lowering, and pain-relieving effects.
Now we know that the heat from chili peppers isn't a taste, but a pain sensation. So, if you're not good with spicy food, don't force yourself, as it can cause pain. Now, let's get to know chili peppers better. Chili peppers come in many types and varieties, known for their adaptability, rich nutrition, and extensive industrial chain. As an important solanaceous vegetable, they are widely cultivated across the globe. Chili peppers are one of the most important vegetables on Chinese dining tables. With an annual planting area of over 1.3 million hectares, they are the second largest vegetable crop in China, right after Chinese cabbage. The production and processing of chili peppers have significantly contributed to increasing the income and wealth of Chinese farmers. Chili peppers, also known as sweet peppers, cayennes, red peppers, or hot peppers, are herbaceous plants in the capsicum genus of the Solanaceae family. They can be either annual or perennial. Chili peppers originated in South America, in regions such as Bolivia, Paraguay, and Mexico. They began spreading to other countries during the 15th to 16th centuries and have now become the third largest vegetable crop globally, after beans and tomatoes. Chili peppers are grown in temperate, tropical, and subtropical regions worldwide. We'll explore the biological characteristics and growth environment to learn more about chili peppers. Learning objectives for this lesson. Knowledge objectives. 1. Understand the morphological characteristics and growth and development cycle of chili peppers. 2. Learn about the environmental conditions required for growing chili peppers. Skill objectives. 1. Accurately describe the biological characteristics of chili peppers. 2. Develop a production plan based on the growth environment of chili peppers. Caliber objectives. 1. Cultivate qualities of hard work and perseverance. 2. Foster an awareness of independence and proactive learning. 1. Biological characteristics. To grow chili peppers well, you must first understand their biological characteristics. We will explore them from two aspects: morphological features and the growth and development cycle. 1. Morphological features. Roots. Chili peppers have a shallow and weak root system, with a high degree of cortification and a slow root mass. The taproot penetrates shallowly into the soil and grows slowly. When the plant has 2 to 3 true leaves, it develops more secondary lateral roots. The base of the stem rarely forms adventitious roots, and damaged roots have poor regenerative ability. The main root cluster is located at a depth of 10 to 15 centimeters, with the primary root zone spreading horizontally within 40 to 50 centimeters of the soil, making chili peppers neither drought-tolerant nor waterlogging tolerant. Stem. The stem of the chili pepper is erect, with a relatively short main stem. The plant has a small crown and a compact shape. After the main stem has produced a certain number of leaves, flower buds begin to form at the tip of the stem. Chili peppers exhibit two main types of branching and fruiting habits: indeterminate branching and determinate branching. Leaves. After chili peppers germinate, the first to appear are the cotyledons, followed by the true leaves. The true leaves are simple and alternate, with a smooth, slightly glossy surface. They are green, and the color varies among different varieties. Flowers. Chili pepper flowers are bisexual, containing both male and female parts. They consist of a calyx, corolla, stamens, and pistils. Typically, the flowers are white or greenish-white and are self-pollinated. When the plant has 3 to 4 true leaves, flower bud differentiation begins, and it takes about 30 days from flower bud differentiation to flowering. Fruits. Chili pepper fruits are true fruits that develop from the ovary, with the edible part being the pericarp. It takes 25 to 35 days from flowering to the maturation of commercial fruits and 45 to 60 days for physiological maturity, red ripening stage. In winter-protected cultivation, this period may extend to about 100 days. The fruits come in various shapes, with 2 to 4 locules, and weights ranging from a few grams to 400 grams. Seeds. Chili pepper seeds are flat, slightly wrinkled, kidney-shaped, and light yellow or off-white in color. Fresh seeds have a glossy appearance. Small seeds typically weigh 5.2 to 5.8 grams per thousand seeds, while larger seeds may weigh 6 to 7.5 grams per thousand seeds. The seed lifespan is generally 5 to 7 years, but the safe usage period is only 2 to 3 years. 2. Growth and development cycle. The growth and development cycle of chili peppers refers to the entire process from seed germination to seed production. This can be divided into 4 stages: germination, seedling, flowering and fruit setting, and fruiting. Germination stage. This stage starts when the seed begins to sprout and ends when the first true leaf appears, breaking through the seed coat, lasting about 10 to 15 days. After seed priming and sowing, it usually takes 5 to 8 days for the seedlings to emerge. About 15 days after emergence, the first true leaf will appear. Seedling stage. This stage begins when the first true leaf appears and lasts until the first flower bud appears. It can be divided into 2 phases. Before the plant has 2 to 3 true leaves, it mainly undergoes vegetative growth. When the plant has 4 true leaves and the stem diameter is 0.15 to 0.2 centimeters, flower bud differentiation begins, at which point vegetative and reproductive growth occurs simultaneously. Flowering and fruit setting stage. This stage begins with the appearance of the first flower bud and ends when the fruit sets. It generally lasts 10 to 15 days. Fruiting stage. This stage starts when the first chili pepper fruit sets and ends when harvesting is completed. The duration of this period varies depending on the growing region and cultivation method, typically lasting 50 to 120 days. During this period, both seedlings and fruits grow simultaneously, with periodic peaks in vegetative and reproductive growth. Fruit setting also follows a periodic pattern. 2. Requirements for growth environment. Temperature. Chili peppers are a warm weather crop. The optimal temperature for seed germination is 25 to 30 degrees Celsius. If the temperature exceeds 35 degrees Celsius or falls below 10 degrees Celsius, germination will be poor or impossible. The optimal temperature for chili pepper growth and development is 20 to 30 degrees Celsius. When the temperature drops below 15 degrees Celsius, growth and development are hindered, and sustained temperatures below 12 degrees Celsius can cause damage. If the temperature falls below 5 degrees Celsius, the plants are susceptible to cold damage and may die. The ideal day-night temperature difference for chili pepper growth and development is 6 to 10 degrees Celsius, with daytime temperatures of 26 to 27 degrees Celsius and nighttime temperatures of 16 to 20 degrees Celsius being the most suitable. Light. Chili peppers require moderate light intensity and can tolerate low light. The light saturation point is 30,000 to 40,000 lux, and the light compensation point is 1,500 lux. Although chili peppers are short-day plants, they can adapt to long-day environments, and their cultivation does not require specific day length. Soil and nutrients. Chili peppers grow best in fertile, organic-rich, water and nutrient-retentive, well-drained sandy loam soils with a deep soil layer. The optimal pH range is 6.2 to 7.2. Due to the weak development of the root system, chili peppers are prone to viral diseases when grown in saline alkali soils. During the growth and development cycle, chili peppers require a sufficient supply of macronutrients such as nitrogen, phosphorus, and potassium, as well as micronutrients like calcium, magnesium, iron, boron, molybdenum, and manganese. For every 1,000 kilograms of chili peppers produced, approximately 3.5 kilograms of nitrogen, 0.8 kilograms of phosphorus, 4.5 kilograms of potassium, and 0.9 kilograms of magnesium are needed. Throughout the growth and development period, chili peppers have the highest demand for nitrogen, accounting for 60%, followed by potassium at 25% and phosphorus at 15%. Water. Chili peppers require moderate water, but due to their underdeveloped root system and weak water absorption capability, they are neither drought-tolerant nor waterlogging tolerant. Irrigation methods for chili peppers can be selected based on specific conditions, such as sprinkler or drip irrigation, to ensure adequate water supply without overwatering. Currently, most cultivation uses drip irrigation to maintain adequate soil moisture while preventing excessive humidity in the air. This lesson ends here. Thank you.